CPCTC. Oh, this is going to be a big one, guys. Our goal again. We have two objectives. Use CPCTC to show two angles or sides congruent. Okay. So, what is CPCTC, you ask? Well, CPCTC means corresponding parts of congruent triangles are congruent. So we've talked about correspondence, okay? But now we have a theorem, corresponding parts of congruent triangles are congruent. Now we have a theorem that we can use in proofs. So let's say I had two triangles. Okay. And I'm given that AE is parallel to CD and B is the midpoint of CE. I want to prove that AB is congruent to DB. So here's the thing about CPCTC. It can only be used after saying one triangle is congruent to another triangle. You may not use this before you prove triangles congruent. Okay? It can only be used after we prove two triangles are congruent. So what's the tip-off that I need to be using CPCTC? Or corresponding parts of congruent triangles are congruent. CPCTC. Well, first off, I have two triangles. That's the first clue. Second clue is I'm trying to find some sides. Now, I could use this to find angles as well, but for this particular proof, we need sides. And I don't really know anything else about these sides. So I'm going to go back here and see if I can't prove these triangles congruent. Well, B is the midpoint of CE, so I know these two segments are congruent. And these lines are parallel, so this angle and this angle are alternate interior and equal. And angle C and angle E are congruent because they're alternate interior. Well, that gives me angle, side. I don't know if these lines over here are congruent. I just know they're parallel. But I do know that EB and BC are congruent because of the midpoint idea. So there's angle, side. So I'm going to write by. So let me write this proof and get to proving these two triangles congruent. And then I'll show you how we can prove these two segments congruent. So 1, AE is parallel to CD, and B is the midpoint of CE. Why is that? It's given. All right, I'm going to use my midpoint idea. AB is congruent to BD by definition of midpoint. I'm going to go back to this idea of parallelism and use that. So I'm going to say that angle A is congruent to angle D, and angle C is congruent to angle E. Alternate interior angles are congruent. Okay, now for those of you thinking, but Mrs. Northrop, what about the vertical angles? I could have used vertical angles as well, but that might have ended up being angle side angle. So just keep that in mind. Your congruence statement might not be the same. All right, step 4, I'm going to say that the triangles are congruent. So I want to make sure that the angles match up when I write it out. So A is congruent to D, E is congruent to C, and B is congruent to itself. And this was by angle side. So now that I have these two triangles congruent, I can use this congruent statement to say that anything about the two triangles is congruent. And what I specifically want to say is that AB, the first and last, is congruent to DB. And why is that? Well, because CPCTC, corresponding parts of congruent triangles, are congruent. And with that, I should be back tomorrow. Have a nice night.